Okay, I am going to talk to you about sine rule today, and you will notice that I have a triangle which is already drawn, and they are labeled as A, B, and C, and they are labeled in uppercase letters, and the letters are in different colors. So the sides labeled in uppercase, the angles are labeled as the uppercase letters A, B, and C. Okay, and if you have a look at angle A over here, which is in red, the side opposite to that angle is labeled as lowercase a, and the side opposite to angle B is labeled as lowercase b. The side opposite to angle C is labeled as lowercase c. And from that we can write a simple rule. Let's say sine A over A is equal to sine B over B is equal to sine C over C. And you must be wondering how on earth can we use those three rules together. In fact, you only use them in pairs, you don't use them in threes. And I've written down over here that you could use them like this. So you have sine A over A is equal to sine B over B, which I have highlighted over here in yellow. And sine B over B is equal to sine C over C, and you'll notice that is highlighted in orange. So, and the last one there, the last pair could be sine A over A is equal to sine C over C, and that is in green. So let's go and have a look at an example over here. And so over here, example is to calculate the unknown angle marked as theta in the following diagram. So in this particular triangle, you will notice that I have the side opposite to angle A is 20 centimeters, side opposite to angle B is 15 centimeters, but I have no idea what that angle B is equal to. So I am going to use this rule over here, sine A over A equals sine B over B, and I'm going to substitute in there. So the values that I have is, just write this again. I have sine of 40, which is angle A, is divided by 20, which is the length of, so this is not C, this is A over here, that's my mistake. Okay, so A is equal to 20 centimeters. Okay, and then the side opposite to angle B is 15 centimeters, and we have angle theta over here, which is marked for angle B. Anyway, so if I'm going to solve for sine theta, what I can do is I can actually go and write this as sine 15 times sine of 40 is equal to 20 times sine of theta. In other words, I am going to cross multiply these over here. So when I cross multiply, I get 15 sine of 40 times 20 sine of theta. Solving for sine theta gives me 15 sine theta, and then sine theta is equal to 0. So you solve all that, and sine theta gives sine theta is equal to 0.48209. So theta will be sine inverse of the answer you get over here, which is 28.822 degrees, and rounding that to 1 dp will give you 28.8 degrees. However, if you have a look here now, the thing that I have marked in green. So from here, you could have actually written this as theta is equal to sine inverse of that bit down there, and you will end up with this particular answer, which is 28.8 degrees. So you avoid doing all these extra writing, and I tend to normally do this bit over here quite a bit. So I will go and do theta is equal to sine inverse of the whole ratio over here, which is given as 15 sine over 40 divided by 20. But I mean, you can decide what you want to do. If you want to go in steps like the way I have done in yellow, that's fine. Or if you want to go and do the way I've done it in green, that's fine. The choice is all yours. Okay, I want to move on and just very quickly have a look at another example. So I'll change the pen over here. Okay, so let's have a look at example. Oh, this pen is too thick. I need to change this. Okay, let's see. Example 2. Now, in example 2, I want to calculate the length of the sides. So, and here I got A, B, and C. So A over here is 30 degrees, and let's say this is X, and this side over here is 25 degrees, and let's say this is 12 centimeters. Now, if you are going to calculate the length of the sides, then it's easier to write your sine rule as A over sine A is equal to B over sine B, which is equal to C over sine C. So for my example over here, I am going to use, because what's given over here is angle A and angle C, so I'm going to write A over sine A is equal to C over sine capital C. So angle A I have is 30 degrees, but I don't know what is the length of the side A, so I'm going to put on X is equal to sine of 30 degrees is equal to side C is 12 centimeters divided by sine of 25 degrees. Okay, so I can now rearrange this. So if I multiply both sides by sine 30, I will end up with this over here. X is equal to 12 times sine 30 degrees divided by sine of 25 degrees. And you will end up with this, which is equal to, so sine of 30 is 0.5 times 12 is going to be 6 divided by sine of 25. So 6 divided by sine 25 gives me, so let's, if we do all that, that is going to come out to 14.197. I'm going to round this to 14.2 centimeters, correct to 1 dp. So if we are working out the, let's say, the length of the side, then you see it's a good idea to write your formula using this in this manner or in this way. So this is for calculating sides, and the other over here right on top, these ones over here are for written like this, so calculating angles. Okay, that's it. Thank you.